is about differentiation. The parametric equations of a curve are, we need to find the dy dx. Show that dy dx equals cotangent t. So the first step is to find dx dt and dy dt. So the dx dt, the derivative of x with respect to t, the derivative of 2t is 2, the derivative of tangent is secant squared. And for the derivative of ln sine 2t, so the derivative of ln x is, so just look at the formulas here, tangent becomes secant squared, ln becomes 1 over x. So what we get is 1 over sine 2t, but we have to use the chain rule because the argument is not a simple t or simple x, so we have to use the derivative of sine 2t, which is sine becomes cos here, so this is from the chain rule. And because the angle we are dealing with now is not a simple t or a simple x, we have to use the chain rule again. The derivative of 2t is 2, so this is the derivative of dy dt. Now to find the dy dx, just use this MF19 formula, this chain rule concept. Dy dx is dy dt dt dx, because if you just simplify like usual fractions, this is actually dy dx. Now the dy dt is exactly like this. The dt dx is not like this actually, because this is dx dt. Dt dx would be the reciprocal, so we flip this upside down, it's gonna be 1 over 2 minus secant squared. So now how do we turn it into what we need to prove? So for the sine 2t, if you look at what we need to prove, it's not in terms of 2t, it is in terms of t. So we're gonna have to use the sine double angle formula. So sine 2t equals 2 sine t cos t, because of the MF19 sine double angle formula. Now for the 2 cos 2t, we have many options here, so we're gonna have to use one of them. So since we don't know yet what we need to use, so let's just keep it as 2 cos 2t. Now for the secant squared t, this is the definition of secant, which is not in the MF19. Secant is 1 over cos, so secant squared is 1 over cos squared. Because we have a fraction inside a fraction, this is complicated. Let's just multiply both sides by cos squared t. So in the numerator we have cos squared t, and in the denominator 2 times cos squared t, and when you multiply here they cancel out, it's just 1. So now we have cos squared t over 2 cos squared t minus 1. Now as you can see, 2 cos squared t minus 1 here, now we know which cos 2a formula we have to use, and that'll be the one with the 2 cos squared minus 1. So instead of cos 2t, we use 2 cos squared t minus 1 now, because now we can cancel out, and we can cancel out the 2 as well, can cancel out the cos t and one of the cos t above here. All we have left is cos t over sine t, which is cotangent t, because this is the MF19 formula, tangent is sine over cos, and this is the definition of cotangent, which is not in the MF19. Cotangent equals 1 over tangent, so therefore it's the reciprocal, it is cos over sine. So again, cos over sine is cotangent. So that's what we need to prove. Alright, I'll see you again next time.